Okay, everyone. Thanks for having me here and seeing such lovely faces. I'm Fabian, one of the founders of Dirty Paws Studio in Klagenfurt, a small indie game dev studio part-time, focusing on, obviously making games, but also all types of gamified experiences, it turns out. And I'm also part-time lecturer at University of Klagenfurt. But what I'm going to talk to you today is, sorry for viewing here, I have no screen here, is our journey of gamifying electrical installations in our video game Electric Alps. But our story doesn't actually start in Klagenfurt. It starts at the countryside, 50 kilometers outside of Klagenfurt at my parents' house, which I'm now doxing. More specifically in the basement. It's not the Mac. Yeah, so leading back to Yvonne's case of being in our parents' basement. Yeah. Okay, so our story actually started in my parents' basement, where my dad asked me and my brother to wire his wonderful woodworking shop. He needed some new lights, some new appliances for his woodworking, and I went to higher technical school of electrical engineering, same as my brother, so we kind of were up to the task, not officially, but we could do it. So, oh yeah, all the slides are in there, I want to skip. Anyway, at that time, I thought about, I played this game, Why to Learn. It's a wonderful game about, a puzzle game about machine learning. Just skip through a bit. So, I thought about, while wiring the electrical engineering stuff, could this actually be a game? Reading from literature by Jesse Schell in his wonderful game design book, he mentioned that one of the defining aspects of a game is that it has goals, it has rules, and it has interactivity or feedback. And these are all aspects I find in wiring. We have goals. I want to switch this light with this switch. We have rules. Obviously, electricity has a type of flowing and a type of making a short circuit, etc. And we also have interactivity, feedback, and strategies. So if I wire the wrong thing, the power goes out. Yeah. So this kind of led us to our vision. Let's make a game about it. So our premise was we want to turn these circuits from my parents' basement into an actual puzzle game. And what was important for us, we didn't want to do an educational learning game. That's what we did sometimes in the past. We wanted first and foremost a puzzle game. It should make fun. And if you learn something in the meantime, it's good for you, it's good for us. But it's not our first and foremost intention. So we started out with a little bit of digging into literature, talking to electricians, talking to old teachers. How does electricity actually kind of look like? It's invisible, but how could the visuals be made? Because we want to see how it was done visually. And warning, it's a change of brightness incoming. I didn't know how bright the room will be. But yeah, that's pretty much what we were dealing with in literature. Just going to skip through it. There were worse gamified experiences. There were better ones. There were some textbook 3D-ish illustrations of how devices should be wired. So we thought about, okay, we can work with that. So we started prototyping. Before we wrote any type of code or even jumped to the machine, we tried a little bit about doing actually paper prototypes using pretty much everything besides paper. So I grabbed a bunch of materials from my basement this time, tried to teach my colleagues, which didn't go to a technical school, and I tried to teach them in a kind of a gamified way how electricity flows, how they could wire a power socket, in this case some speakers, lighting installations like these circuits in here. You push once, it turns on, you push again, it turns off, etc., etc. And when we tried it out, how could it actually look like? based on these additional electrical wiring plans. So these were our first remote sessions shortly after COVID. So where our team is somehow split up over the globe with some friends working from LA. And Andy back then wasn't with us, but we had some session with him being in Korea. So it was kind of a strange time zone issue. And so we moved from prototype to prototype. This was our first digital prototype where we just had to drag some things around in Adobe Illustrator. And this, I hope it works. I have no internet connection, I'm so sorry. Yeah. How can I switch it back? Yeah. There was supposed to be a video, but that means you have to go to our booth and actually play the game to see how it looks now. Yeah, basically, that's the current state of our game, where we made the visual a little bit more appealing, but it's also more interactive. But that wasn't kind of a... I'm so sorry. Everything was supposed to be online. But I will figure it out. Okay, but it wasn't without any challenges. The biggest challenges we had to resolve was the eternal struggle between realism and abstraction of all these real-world aspects we had in our game. First and foremost was the visuals. You've seen the plans before. They were very convoluted, and those ones which weren't convoluted, they didn't convey as much information. So in our case, it is a game, but the visuals, as in pretty much every game, isn't only about the aesthetics. For us, it was important to convey all the information the player needs to actually solve the puzzles and understand and even see the puzzles. It also needs to be easily readable in the first glance and also be consistent. And what was also important for us, we don't want to make a too abstract game, like just wiring some abstract elements on a black screen, something like that. We actually want to present all these puzzles and circuits you have in their context, which means if you have lighting switching of a fictional living room, we actually want to present you this puzzle in a gamified living room. And also we wanted to have the devices in the game recognizable, not necessarily realistic. Like you see here, there are lots of locational differences for power sockets. So if you've been to Italy, they have different ones. If you've been to the UK or US, pretty much every region in the world has different types of power sockets. We didn't want to address that, so we kind of made an abstraction for that. The second one was a little bit more of a technical nature. We have a game about electrical engineering, so we need to simulate the electricity. And we were driven by the question, how realistic is realistic enough? We don't want to do a simulation, because that means I wouldn't be standing here. I would be sitting in my office for the next 15 years and doing an electricity simulation or buying a $30,000 license to some kind of a simulator. So again, we abstracted this and simplified it. And for us, it was important that the expectability of the electrical simulation overweights the realism. But it was also important for us that pretty much every reasonable household installation is also doable in game. And I think we've reached that goal. So if you have some kind of light switch in your house, it can also be done in this game. And the last challenge, the last of the main challenge, was also the difficulty to balance the gameplay, so how the gameplay is, what we want in the game, with their educational value and the realistic counterparts. Little bit more abstract if you're not working in the field, but in generally, when you're wiring something as an electrician in real life, there's kind of two-stage wiring. First, you connect all the different parts of a room together with the wires, and typically if you do a mistake there, you have to redo it again because it's just not easy to shove an additional cable in there. And then once you have that, you connect inside these individual boxes, the device and the wires to each other. And we could have moved away from that and just replaced everything with a single wiring system, but we wanted to keep that in there because it's such a different way of thinking, because you just have to think at first, how am I going to solve the puzzle, and then work your way from a top scale down. And also the biggest discrepancy and also kind of a pain thingy when talking to real electricians is that in our game, you're wiring while the power is live. You should never, never do that. It literally may cost your life. But without this, if we kept it realistic, we should turn off everything, which means eliminating pretty much every type of feedback we could give the player during the wiring phase. So that means if you connect something correctly, you immediately see the results. And for us, that's very, very important for a game. And yeah, in total, we're looking that the fun is more important than the realism. So if that's one takeaway from my session, it's that one. And if you want to actually see how the game looks like, please join us in our booth, and thank you.
And you got a present.
What a lovely surprise. Thank you.
What a surprise. We are a little bit behind schedule, but we will manage. It's not a race yet. One question, any question? Cool. Then give it up, please, one more time.